Hello Science 30 and welcome to our video on the hazards and issues with organic compounds. Today we're going to be looking at the dangers of being around different organic compounds and how it can affect your health. So we're going to start today in a very specific area with building materials. So we're going to start looking at a variety of different compounds in different areas that you might be exposed to in the environment where you live, where you work, and stuff like that, and how it affects you. So the first thing we're going to talk about is off-gassing. Now, off-gassing is the release of volatile organic compounds, or what we would call VOCs, from building materials. So when you enter into a building that is freshly designed, newly finished, that smell of fresh paint, that is an example of a VOC, or the volatile organic compound. Now, the reason why you have to be careful of volatile organic compounds is because when you are exposed over a period of time, you can have reactions like nausea, dizziness, maybe you feel headaches and things like that. So when you move into a new building, a lot of times they've done indoor air qualities to ensure that the evaluation of the air that you're going to be living in or working in within that room or structure is not high. So it's looking at the paints and solvents are 100% dry, that the VOCs have evaporated and are not hanging out in the air and then eventually going to make you sick. That's why there is usually pause or wait times for people to actually move into a new building. So another thing we're going to talk about is pesticides. So there's another set of definitions along the side here. So VOCs, or off-gassing, is like one world, living in a structure or a building. Pesticides now look at the different interactions within our environment. So a pesticide is essentially a substance that's meant to kill a fungi, insects, animals, or plants, anything that we would consider a pest. So the three broad categories we have are insecticides, herbicides, and fungicides. The idea is that if you look at the root word of each, insect, herb, and fungi, it tells you which it's trying to get rid of. So an insecticide is trying to remove insects that damage damage or cause disease in domestic locations, agriculture, or forestry. Herbicide is getting rid of weeds, or plants that are unwanted that compete for nutrients and sunlight. And then a fungicide is usually protecting crops and plants from fungi that can cause disease or mold growth on food. So the different types of organic compounds that you can find within these is insecticides have halogenated hydrocarbons and VOCs. Herbicides have VOCs, and then fungicides tend to have phenols. And then all of these can interact within your body in different ways and cause reactions. So when we're looking at pesticides, we have to look at some important things because we know we need to use pesticides. We know that there are reasons why it's important to have them, but we really have to take a big look at a big picture. So one thing we have to start with is, what is our target specificity? If I am spraying something in an area, what range of organisms are affected by that pesticide? So I really have to look at the risk versus benefits of spraying this pesticide. The other thing I have to look at is my pesticide targeted? Am I trying to only get one specific pest? So when you're looking at the broad spectrum, it's a chemical substance that we are going to spray that controls a large variety of populations within the area you're spraying. So if you want to get rid of a bunch of stuff, you're wanting to look at maybe what does a broad spectrum offer you. The other part we want to look at is the toxicity. So the ability to cause damage to living tissues, or impair the body functions of the body system, or cause death when ingested, inhaled, or absorbed through the skin. So what are you trying to target? Would it be better to use broad spectrum, and how dangerous is it? Is kind of the three things we want to consider when we're trying to do pesticides. So here is a video about an important scientist that helped the United States through what we would call a national health crisis. Hopefully if you had a chance to view this with your teacher ahead of time. If not, there will be links to watch this on your own, but it's a good idea to see the considerations that were taken in when this scientist was trying to decide what was this one drug that was given into the population, was it safe or not? So she had to consider, what was the target? Did it cover a large range of things? And what was the toxicity to the individuals that were taking this drug? So what we're talking about with toxicity is this idea of lethal dose and lethal concentration. So when you ingest anything that is chemical, so think Advil or even Tylenol, there is a dosage you are allowed to have, and the concentration that can happen with different things, such as in water, that can kill 50% of the population. So dosage is within we would say ingested by people, concentration is found in water. So LD50 is a concept that we cover in Science 9, something you may remember from a while back. And it's the idea that you are going to put a chemical substance out there, and once it kills half of the population, then you know its lethal dose. It's LD50. And we measure that in milligrams per kilogram. So things like caffeine has milligrams per kilogram. Arsenic, that's like very dangerous, right? Lead and mercury, all of these things have different LD50s because it's how much can a body take in before it would kill 50% of the population. The other side is LC50, which is new, is the concentration of a chemical substance in the water that kills half of the population that was in the water. So instead of milligrams per kilogram, we measure this in milligrams per liter because we're looking at the volume or the amount of water. So this is a pros and cons video to pesticides. So it kind of looks at the it looks at taking in the considerations and what are the pros and cons to actually using the pesticides. And then it also looks at when it's the cons, is it taking a risk benefit analysis in the sense that you want to know, is it going to overall be an adverse thing or could it be positive within the population? Again, this is hopefully something you've seen. If not, links will be given. So these are, again, things to consider when we're using pesticides. So we talked about toxicity, we talked about broad spectrum, we talked about targeting, but now we also have to think about how dangerous is it in the environment and what can happen. So one thing that can happen is persistence. What this means is that a chemical can be stuck in the atmosphere or within the environment for a long period of time and never broken down. Some things can persist for a really long time. Some things can be broken down biologically or through chemical processes fairly quickly. Another one we have to look at is what we would call drift. So how long does it last in the environment is persistence, but drift is if we spray this pesticide or put it somewhere, can it be transferred to other areas that we do not want it to actually target? Will we end up causing damage to other areas around the location where the pesticide was sprayed? Will we kill animals? Will we kill plants? We have to look at the drift part of the considerations. We also have to know what is called grasshopper effect. Grasshopper effect is when something transports the pesticides that results from their evaporation in warmer climates and condensation and deposition in colder climates. So what that means is if you spray a pesticide in a very warm area, it's going to evaporate and get into the clouds and then eventually get put into the sleet, snow, or rain. If those clouds move into an area where it's cold climate and precipitation falls, what happens is it deposits it into the colder climates and then it persists longer because it's in frozen water or it's stuck in a cooler climate where it cannot evaporate out. So that is called the grasshopper effect, jumping from one place to another by the means of transportation through water. So the next concept we're going to talk about, so we talked about off-gassing, which is within the environment, within a building and structures. Pesticides are in the environment, kind of considerations and dangers we have. And the next idea is biomagnification. So you're going to watch this Amoeba Sister video with your teacher. Hopefully you've already seen it. If not, again, pause this one, go find the link and watch this to learn about how pesticides can be transferred through trophic levels. Now, trophic levels mean things like a piece of grass is eaten by a mouse is eaten by an owl, okay? Those are feeding levels, trophic level 1, 2, and 3. So the grass is level 1, the mouse is level 2, the owl is level 3. And as things get eaten, you are going to, if there's pesticides on those things, you're going to end up getting more and more pesticides in your body. So this is an example you are going to do with a partner or on your own and then discuss with your teacher. This is a describing and trying to figure out things about LD50, disadvantages and advantages of pesticides, information using the table. There will be an answer key posted to help you check your answers. So some more considerations that we have to talk about when using pesticides is not only do they persist, is how long do they last in the population. So hopefully now you understand that biomagnification means the passing on of toxicity up a food chain. So as things eat other things, they get more and more toxicity. So you really have to look at how very carefully how that affects populations. You also have to look at if you're spraying a lot of pesticides all the time, what happens to the population if it becomes resistant to your pesticide? So all of a sudden now you have a type of bug or plant or something that no longer is affected by this pesticide. This happens when mutations create variations in a population. So you have a little bug, it's like all the other bugs, but for some reason a small mutation happened in its DNA that makes it harder to kill with that pesticide. So if you look at this picture here, here's my mutated bug. We spray a pesticide, it kills most of the bugs. It won't be 100% every time. But what you're going to see here is only the blue ones died. So most of the blue ones died, we were left with a few. What happens is in the next generation, when they breed, there's going to be new red bugs, which are resistant to our pesticide. And it's going to now increase each time we spray that pesticide because we're killing off the one that is able to die using our pesticide, but not the one that is resistant. So eventually you're going to start creating what we call superbugs, bugs that no longer die or are affected by chemicals because they've mutated and have gone past that process. So the development of pesticide-resistant populations is a result of poor pest management practices, meaning we've relied way too heavily on one product in our use of pesticides, and now we have bugs that are resistant to it. So the idea when we're using pesticides is that you want to alternate the type of pesticide used to increase the ability to control your pest resistance rather than just one type of pesticide. So here is a toxic substance list. Okay, so this is what we are looking at when we're talking about toxicity. We want to know, is it persistent in the environment? Will it accumulate in the environment? And is it toxic to the environment? So when you're looking at pesticides or VOCs or anything that goes into the environment or into your building, toxic substance lists is looking at these three points. Does it persist? Can it accumulate? And is it toxic? The reason is because it'll evaluate on whether or not we want to use that product or not. Now, other categories that we are going to take into consideration, especially for humans, is what is the potential for exposure? So when you spray, are you in an open field or are you in an enclosed space? Okay. And then the other one is it inherently toxic to the environment, but also is it inherently toxic to humans? We want to be very careful that we look at all of these to decide whether or not a pesticide, such as a fungicide, herbicide, insecticide, paints, if they should be used around humans, plants, or animals, because if not, it could cause massive effects. So the effects of chemical exposure, okay? And this is where we're going to leave off, and then the second video is going to pick up with water quality. So we've kind of looked at the effects within the environment, and we're going to look at water quality after. But there are products called D2,4-D, which include chlorinated dioxin compounds. Now, chlorinated dioxin compounds have a number of adverse health effects in humans. So when they started using these, we didn't really look at the 5 things. Is it toxic? What is it persistent? Does it accumulate? Is it harmful to the environment? Does it have exposure? And is it bad for humans? Well, it turns out it's really bad for humans. It decreases your immune system, it interferes with the hormone system, and it can cause cancer. Okay? So this similarities between the chemical shape of the female estrogen hormone and dioxin are what scientists believe allow dioxin to act as estrogen within the body. So what this does is this synthetic compound mimics estrogen and can influence reproductive cycles, fertility, meaning you could be infertile, or behavior in a variety of different organisms. So this is one of the reasons why I talked about those 5 things and why each time we consider using a pesticide or a chemical, why we need to really think it through, because there are large consequences that can occur. So I hope you were able to watch all the videos that were extra in here, prior or after. Answer those questions, which will have the answer key posted. And if you have any questions, please let me know.